Hello, welcome. Let's try to solve another Leetcode problem. 1177. Can make palindrome from substring. So we are given a string S, and we want to find some substrings, and all those substrings is found by queries. So for example, for query 3 and 3, we get a character D, and this is 0. I mean the third index inside of the queries means how many characters we can I think we can replace in the substring. But for the first one, it is just a D. We don't need to place anything. Even then that k is 0. This means we cannot replace any number. But for this character D, it is a palindrome, so it's gonna be true. Let's check the second one. So for 1, 2, it is BC. BC is not a palindrome, and we cannot use any replacement because k equal to 0. So it's gonna be false. Now 0, 3, it's gonna be ABCD. So for ABCD, we can make one replacement. So here comes the problem. Can we make one placement to make it a palindrome? So for example, we can replace A with D, but it's not a palindrome. So let's just use this example to get our formula. So for A, B, and C, D. So all those characters are unique and with odd numbers. I mean not even numbers. 1A, 1B, 1C, and 1D. And how many replacements do we need? We need at least 2 replacements. So if k equal to 1, it's going to be false, but k equal to 2, it's going to be true, because we need 2 replacements. But how can we calculate this kind of a formula? And this is going to be easy. So for example, if it is odd, so for A, B, C, I mean there are odd numbers. So we're going to count how many odd characters. So there are 3 odd characters. And for this one, there are 4 odd characters because A has 1 time, B1, C1, and D1. So if it is even, so we're gonna check how many odd characters. There are 4. So 4 gonna be divided by 2, and we're gonna take the floor, so it's gonna be 2. It means at least we're gonna need 2 replacements. And what about it is 3? 3 gonna still be divided by 2, and we're gonna take the floor of the result. It's gonna be 1. It means we need at least 1 replacement. So for example, we can replace A with C, or we can replace C with A. It's gonna become a palindrome. Because for this B is okay. So for this example, B is in the middle. But this B is not fixed. It can become something like ACB. It's also the same because C is in the middle. We can replace A with B. So BCB is also a palindrome. So this is the first formula we're gonna need. We're gonna check how many numbers of odd characters, and the result gonna be the number divided by 2. We're gonna take the floor. So this is the first formula we're gonna need. The second is that let me make another drawing. So the second is that while we are checking the queries, so for example, we have something like A, B, and C, D, A. So while we are checking the queries, so for example, the queries is just from 0 to 4. So this is 0 and this is 4. We are going to check this string like A, B, C, D, A, but it can be reordered. But even that it can be reordered, we have to so we have to check one by one to get the result, and then we're gonna put it inside a counter. But it's gonna still be O(n) time for each of the queries. So for example, if you want to check from 0 to 4, basically you need to collect A, B, C, D, A inside a counter. It's gonna be O(n) time times 26 times 20 times 26. You're gonna get the result. But for our problem, the query should be just in O(1) time or O26. It should be okay. But it cannot be O(n) times 26. This means we cannot use O(n) time for the query, because basically there are n queries, and each query is n. And it is n squared times 26. It's going to be a really large number, and this n is 10 to the power of 5. So this means we cannot use this kind of solution. Yeah, so this comes to the prefix sum. Yeah, so for our problem we have like AB and CDA. So we can use prefix sum to solve the problem, but our prefix sum gonna be a 2D array, not 1D array. So we're gonna put all the characters. So this is the string. So we're gonna have like here we're gonna put A, B, C, and D, A. And for the first line we're gonna prepare padding. It's gonna be 0. And then for the second line, yeah, for this character A, yeah, so while we are checking this character A, we're gonna have 26 positions. And each of the positions gonna have a record of how many A's. So for example, A should be in the first place, so gonna be index 0. So we're gonna have 1A. So for this B, we're gonna check it from here. So we're gonna have 1B. Yeah, and after that, this A gonna be accumulated to here. So this place is gonna be 1. So this one means up to here, for the prefix sum, we have 1A. And up to here, we're gonna check another one, maybe this one, we have 1C. So C1 will be here. And then for B, it's gonna be 1. And for A, because A is at this position, it's gonna still be 1. And next we have a D. Yeah, let's just finish this calculation. So here gonna be 1, it means 1D, 1C, 1B, and 1A. We accumulated to here. Next, we're gonna check the last one. So here, the strange thing happens. We have another A. So what happens for this A? Because A should be in the first place, the first index. So here gonna be 2 because it's accumulated to 2. And what about this position? How many B's? It's gonna be still 1, and C still 1, and how many? And D is still 1. Yeah. Now up to this position, this is A and this is A. We want to do a prefix sum. We want to check the queries 0, 4 with 1. Yeah. We just to check if it is true or false. So for 0 and 4, so this is a 0 index at this position A, and this is index 4 with this A. So for prefix sum, basically we're gonna use this number, all those numbers minus the first line, the padding. It's gonna always be 0. Yeah. So we're gonna check how many A's. Yeah, let me use another line maybe. So yeah, we're gonna check how many A's. So 2 minus 0. Yeah, how many A's? We have 2 A's. Yeah, but 2 is even, it is okay, we don't count it. And how many B's? We have 0, and here is 1, we have 1B. And how many C's? We're gonna plus 1, 1C. And how many D's? 0. This is 1 minus 0, it is 1. So 1 plus 1 plus 1, we just check the odd numbers. So we have 3 odd characters. So it's gonna be BCD because it has 1B, 1C, and 1D. Yeah. As you can see, if we prepare a prefix matrix, like a 2D matrix like this, basically, while we are checking the queries, we just use O22 time. We don't need to use ON times 22. This is why we can reduce the time to N times 26. So this is going to be the final time complexity. So we're going to solve it like this. First of all, we're going to prepare a prefix matrix. So I'm going to call it a DP matrix. So it's going to be a DP matrix. And after that, I just check each of the queries. So for each of the queries, I just need to check. I just need to check how many odd characters, and this is gonna be O26 time. The time complexity would be O26. At n times 26, gonna be really small for the requirement or the description. So it should be okay for solving the problem. Yeah. Now we can just start coding. I think everything should be clear enough for the coding. Yeah, so we're gonna prepare a DP matrix. So inside of the DP matrix, I'm gonna set it 0 times 26. So for I in range n plus 1. So n is the length of the string S, and plus 1 is the padding, because when you're preparing prefix sum, normally even for 1D array, you're gonna prepare padding. So for 2D array, similarly, you're gonna prepare padding because there's gonna be the queries like from 0 to 3, or 0 to 3, or 0 to 4. So you have to prepare a padding to avoid calculations. Otherwise, you have to check. So to avoid further calculations, we can prepare a padding. So the first line is gonna be a padding. Now we can start. We can start checking all the characters. So for I in range, so we're gonna start from the let's try to use enumerate. So for I say in enumerate the string, so we're gonna enumerate the string, but the start index is gonna be 1. So in Python, inside the enumerate, we can use the start equal to 1. So this just means we're gonna start from the index I equal to 1 until to n. So because the length of the string is n, so it means it's gonna be starting from 1 to n. If we didn't do it, it's gonna be starting from 0 to n minus 1. So if it is starting from 1 to n, it means okay, we can fit the DP array. Now we're gonna fit the characters first. Currently, we didn't do the prefix sum yet, but we will do it later. We just put first of all, we're gonna put the characters inside, right? So the position is like DPI. It means in the ith row. So for example, this is DPI. Maybe I is here. This means in the ith row. And in the ith row, we're gonna put a character. We don't know the position, but we're gonna use math to calculate where it is. So we're gonna use odd with character minus odd a. To find the position. Because index 0 is the character A, index 1 is character B. So we're gonna use this way to find the position of all the characters. So it's gonna be plus equal to 1, because from the beginning it is 0. Or you can directly use it to be 1. It is the same, because 0 plus 1 is also maybe I can use directly. I can make it equal to 1, because it must be at 1 positions. For each of the line there must be only 1 character. So maybe I can save some time. So I will set it to be 1. I mean plus equal to 1 or 1, it's the same. Now we're gonna prepare the prefix sum. So for I in range, so the prefix sum gonna be starting from 1 until to n plus 1. And for j in range 26, because there are 26 characters, and then we're gonna do the prefix sum. So it's gonna be dp I and j would plus equal to dp I minus 1 with j. Now we finished the dp matrix. So we just need to check if it is okay or not. Let me just return an empty array to check what is the result inside the dp matrix or dp array. So inside the dp array, let's just check the queries from 0 to 4, right? So from 0 to 4, maybe let me make it better. So from 0 to 4, so let me try to use another color. So from 0 to 4, this is the index 0, right? And this is the index 4. 0, 1, 2, 3, 4. So from 0 to 4, how many A's? So it's exactly like what I checked before while I'm making the drawing. So we have 2 A's, 2 minus 0. So while we are using the prefix sum, we're going to use this for minus the first line. It's going to be here. So for 2 minus 0, it is a 2, it is okay. But this is 1 minus 0, 1 minus 0, 1 minus 0. This means we have 1B, 1C, and 1D. It means it's exactly the same. It means our prefix sum is okay. Now we just need to finish the second part. So the second part is just to enumerate all the possible results. So let's just enumerate it. So for I, let's just maybe I'm gonna use a variable j. So for j as the index, for j, l, r, and k, enumerate. So for this one, we're just gonna enumerate all the queries. Yeah, queries. So we're gonna put the final result in a result array. So the result array gonna be false times length of the queries. Yeah, I think it's okay. Yeah. So first of all, we're gonna enumerate yeah, all the queries. So for each of the query, we're gonna check how many odd characters. So count should be equal to 0, because there are 26 characters, so we're gonna use I. So for I in range 26, we're gonna have a check. Yeah. So currently we can use the DP array. So it's gonna be DP j. Yeah, let me check. Currently we're gonna use it's not DP j, it is L and R. Yeah, so we're gonna use DP R plus 1. Yeah, because we prepared a padding before. The right side is 3. Now the right side becomes 4. Yeah, because we prepared a padding, so it's gonna be R plus 1. Yeah, and similarly for here, as we prepared a padding before it is 4. Now this 4 becomes 5, so we're gonna use DP R plus 1, and the position is I. Yeah, and minus DP L. So here we don't need to use L minus 1, because L minus 1 plus 1 it is DP L, and with position I. Yeah, so after using the prefix sum, we just need to check the result. If it is odd, if it is modular 2, if it is modular 2 equal to 1, it means it is odd. So if it is odd, so the count, or maybe I'm gonna define it as odd, the number of odd characters. Yeah, how many odd characters? So odd would plus equal to 1. So finally we need to check if odd divided by 2 less than or equal than k. Yeah, it means it is true. So the result position is j. So result j should be equal to true. And finally, we just need to return the final result. Yeah, so this is gonna be the entire code. Now let me just run it first before analyzing the time complexity again by using the code. Yeah, as you can see, it works. Now let's try to submit it first. Yeah, let me just delete the printdp. Yeah, because we use the printdp every time. Now I deleted it, it should be okay. Let me try to submit it again. Yeah, now as you can see, it works. It's not the fast method, but I think this is the easiest way to understand the problem first and try to find a easy way to solve it first and then try to optimize it. Yeah, and then let's analyze the time complexity. The query is gonna be 10 to the power of 5, and s is also 10 to the power of 5. So from here it is 26 times n, and from here it is also 26 times n. So the final time complexity is 26 times n. Thank you for watching. See you next time.